guys, this is Professor Janacek. I want to talk about finding partial derivatives using the chain rule. Now this seems a lot more complicated than it really is. So we can do this in either one variable, two variable. In one variable, dz dt, notice this is an ordinary derivative. What we get is the partial of z with respect to x times dx dt plus, notice this is a summation, the partial of z with respect to y, and then dy dt. If we have two variables, the only difference is that we start off, we just have partials. So the partial with respect to s, notice we now have partial derivatives there, both with respect to s. And then the other variable in this case is t, so then we have our partials here with respect to t. Notice again that differs. Here we had ordinary derivatives with respect to just the single variable. We don't have ordinary derivatives if our function is defined in two variables, so we have those partials there at the end. But let's try an example and maybe this will be a little clearer. So we want to find dz dt for z is equal to xy squared, x is equal to t squared, y is equal to t. So notice z is a function of x and y. However, x and y are both functions of just t. That's one variable. There's my variable t. Okay, so we are going to follow this pattern here for a single variable. All right, so we want dz dt. All right, so to start with, we want to take the partial of z with respect to x. So we start with, here's z, take the partial just with respect to x. That would be simply y squared. And then we're going to multiply that with, this is our chain part, we're going to multiply that by the derivative of x with respect to t. So the partial of this with respect to x, and then take the derivative of x. So that gives us 2t. Plus, now we're going to look at y, the partial with respect to y, and then the derivative of y. Partial with respect to y of z is 2xy, and then the derivative of y is just 1. Okay, so again the pattern is partial of z with respect to x, and then the derivative of x, partial of z with respect to y, the derivative of y. Okay, we can clean this up a bit. We've got 2y squared t plus 2xy. Of course, we also know that x is t squared and y is t. We can make those substitutions, and we end up with 2 times t squared times t plus 2 times t squared plus t. So that ends up being 2t cubed plus 2t cubed. Thus dz dt equals 4t cubed. All right, there we go for that one. Hopefully it wasn't too bad. Let's try example 2. We want to find the partials, the partial of z with respect to s, the partial of z with respect to t, for z is equal to sine of 2x plus y, x is equal to sine squared minus t squared, s squared minus t squared, and y is equal to s squared plus t squared. All right, so let's start with the partial with respect to s. So again, notice z is a function of x and y, but x and y are functions of both s and t. So we have two variables here. Our variables are s and t. Okay, so the partial of z with respect to s, we start by taking, again, I'm looking, if you need, you can follow along up there, the partial with respect to x. So I'm going to take the partial with respect to x, and then I'm going to take the derivative of x with respect to s. Let me say that one more time. I'm going to start by taking the partial with respect to x, and then the partial of x with respect to s. So that gives us the cosine of 2x plus y. I do need the chain rule in this one, so that's actually going to give me a 2 out there. And then I'm going to multiply that by, again, the partial of x with respect to s, which is 2s. Oops. Plus, now we're going to look at everything in terms of y's. So I'm going to take the partial with respect to y, and then I'm going to take the partial of y with respect to s. So that's going to be cosine of 2x plus y. No chain rule here. Well, you could say I'm going to multiply that by 1, but not necessary. And then the partial of y with respect to s. So that gives us times what am I doing? Times 2s. Yeah, there we go. If we clean this up a bit, we get 4s cosine times 2x plus y plus 2s cosine 2x plus y. All right, now here comes the fun part. And let's see, can we... Oh, wait, before I do all that, let me go ahead and combine these. That's 6s cosine 2x plus y. That's nice. All right, now let's go ahead and replace all the x's and y's. We can use the substitutions, oops, right there. So that gives us 6s cosine of 2 times s squared minus t squared plus s squared plus t squared. If we clean all of that up, that gives us 6s times the cosine of 3s squared minus t squared. Combine those like terms, distribute the two, combine like terms, and there you go. There is the partial of z with respect to s. Now let's try the partial of z with respect to t. So again, I'll start by looking at the x's, take the partial of z with respect to x, and then the partial of z with respect to t. So we're just working with the x's now. So let's see, partial of z with respect to x gives us cosine of 2x plus y. Of course, the chain rule says if I take the derivative of this, we end up with a 2. So multiply by 2, I'll just put that in the front. And then we multiply that by the derivative of x now with respect to t, all right? Our partial is with respect to t. That gives us negative 2t plus, now we're going to go through the same thing, but looking in terms of y's. So the partial of z with respect to y, and then the partial of y with respect to t. So what does that give us? That gives us, let's see, cosine 2x plus y. And now the derivative of y with respect to t. Multiply that by 2t. Right? We can clean this up a bit. We get negative 4t cosine 2x plus y plus 2t cosine of 2x plus y. Yeah, looks like we can combine those as well. That gives us negative 2t cosine of 2x plus y. Use our substitution for x and y. Negative 2t cosine of 2 times s squared minus t squared plus s squared plus t squared. All right, there inside the argument of the cosine, we can distribute the two, combine like terms, just as we had done before. We end up with negative 2t cosine of 3s squared minus t squared. And there we go, the partial of z with respect to t. So just once you understand what's going on, it's really not that hard. It is a bit tedious. Just watch those positives and negatives. Make sure you know what you're looking at, taking the derivatives of the right thing at the right time. Enjoy!